reminder, there's a review session for the exam. There's one on Sunday. I will film the one on Sunday, so you can watch it on the web if you can't make it. However, it's probably in your interest to go because really the best way for a review session to work is for you to ask questions and say, I really can't understand Sinzin rule, can you go over it? Or, I can't do a Zinn rule, how do we do it? Rather than, tell me everything that I never learned because I don't know anything. So, watching it is probably less useful than attending, but I understand people have obligations. What else? On the web page for the class, I put up old exams for Math 132. I think one actual exam, 2 practice exams, and an exam for Math 126, which covers some of the same material. The drawback of all of these is the 132 exams were behind. So they all cover volumes which will not be on the exam, although we will cover it just before the exam. So they all cover volumes of revolution. We will not have drop volumes of revolution on the exam. I think one of them covers arc length. Again, we won't get to arc length before the midterm. So, that means that, well, and the Math 126 exam doesn't have any stuff on areas, which we'll do today, nor does it have anything on improper integrals. So none of the 4 or 5 or however many I put up there samples are perfect, but it gives you an idea of what the exams are like. And if you look at all of them, you'll notice that they differ quite a lot. So, anything else we need to cover? No? All right. Yeah. The appropriate ones. How's that? So, look on the web page, buy your recitation. Most of the people in this lecture are in ESS 001, if I put a little arrow there. But one recitation, Yesla Cha's recitation, which I think is, she's not sitting there today, is, maybe she's, I don't know, 7, is number 7, is in, I think, Old Engineering 143, I think. So recitation 7, is in this room, and 6, 8, no, there is no 6. 8, 9, and 10 are in ESS only. And then all the other ones are, if you're in the other lecture, well, look on the webpage to see. Other questions? No? Okay. So I want to apologize at the end of the last class. I put a problem up which the answer was right, but you can't do that problem. So I meant to put up a different problem, so let me put up the different problem. So here's what I put up. So the question was, does this converge or diverge? And really I meant to put up this problem. Or maybe I meant to put up this problem. You should be able to do both of them. Do you want me to ask them the clicker questions? No? Nobody likes the clicker questions? No? Because they make you work? Okay. So, I will just ask, does this converge or diverge?
Diverge.
Why? Okay, so that's wrong. But, see, it sounds good. not right. But okay, it was a good guess. You had a 50-50 shot. And made some argument that would convince anybody but me, maybe. Not anybody, but anybody in this room but me. So, okay, this one actually converges. And the reason it converges is because this is like 1 over x squared. So this is, so since sine of x over x squared is certainly less than 1 over x squared, and it's greater than minus 1 over x squared. And the integral from 1 to infinity of 1 over x squared converges. Yeah. So the sign is between 1 and minus 1 all the time. So this is never bigger than 1 on the top, and never less than minus 1 on the top. Sometimes it's 0, sometimes it's a half, sometimes it's 0.006, but it's never bigger than 1. Right? Okay. So a lot of times in calculus, when you see a sine or a cosine, you should think, oh, maybe I can replace that with 1. You can't always, but sometimes you can, so you should think about it. So here, this is true, well, okay, it's less than or equal to, because for certain values of x, the sign is actually 1. But the sign is always between plus 1 and minus 1. And x squared is always x squared. Okay? So this integral, if it exists at all, is always less than this integral. Well, in absolute value. Because sometimes it's negative. But this integral, we know, converges. And I did that last time, I believe. Right? Did I do 1 over x squared? No? Yes?
Yeah.
Yeah, I did. Because when you integrate x to the minus 2, you get negative x to the minus 1. When you take the limit of x to the minus 1, as x goes to infinity, you get 0. So we're cool. So this guy, I mean, and in terms of a picture, the guy on top, so here's 1 over x squared. Here's minus 1 over x squared. And sine x over x squared does something like this. This area here, we know is finite. It's 1. You know, I can do this out more carefully if you like. But, okay? So your argument was wrong, but it sounded good. To give you, you know, points for trying. Okay, what about this guy? I won't laugh at you. I didn't laugh at him. I like his argument. It's just wrong. Nobody's going to tell me?
Diverge.
Well, yeah, because the other one converges, so geez. Why would I put 2 converges? Okay, yeah, why does it diverge? Because 1 over x diverges, and 1 plus sine x squared of x is always bigger than 1. So, by the same reasoning, well, similar reasoning, 1 plus sine squared of x, well, you take a number and you square it, it's always positive. So this is certainly bigger than 1 for all x's. And x is always the same as x. And so we have that. And this integral, which also we did, this diverges because of what he said. This is a log. Log of infinity is infinity. This is bigger. This is too bad. Too big. And we have something bigger than that. So since this is bigger, and that gets as big as you like, this gets as big as you like. I know this comparison theorem is a little tricky for people. It's a good skill to learn, to be able to look at things and compare them to other things that you know. Of course, you don't necessarily know what you know yet, but when you do it enough, you'll have a better feel. But in general, 1 over x to a power, there was a homework problem that asked about that. And we're going to infinity, and the power is bigger than 1, it converges. If we're going to 0 and the power is less than 1, the integral converges. So, yeah. This guy? Well, it isn't obvious from the picture. There you go. I mean, I can't really draw the picture how it diverges because it looks like it should. And in fact, if you sit down with a calculator or a computer and you start numerically integrating 1 over x, you're going to get a number because it diverges so slowly that you won't see it. But it does diverge because it's like the log. And the log goes to infinity. But the log grows very slowly. The log is an exponent. So it grows, but it grows slowly. I mean, the log of 1,000 is not that big a number. And if we're doing base 10, the log of 1,000 is 3. That's not a very big number. And from 1,000 to 1,000,000, if we're doing base 10, base e is similar. 1,000 to 1,000,000, we go from 3 to 6. You can't just look at the graph. You can look at the graph and draw conclusions when conclusions are warranted. So here I can look at the graph of this and compare it to the graph of this. I know that 1 over x is too big. And I know that this guy, 1 plus sine squared over x, does something up here. It touches, I'm drawing it not touching, but it touches at every multiple of 2 pi. But it does something up here. So if this is too big, certainly that's even bigger. So that really, the comparison theorem is where you look at the picture. But to just look at the integral and say, for sure it diverges. If I give you a penny every day for 1 billion years, you'll have a lot of money. Well, maybe 1 trillion years. But, if I always give you a penny every day, your amount of money is unbounded. But it takes so long that you can't really tell. Yeah? Depends on whether we're going to 0 or infinity. So there's a homework problem like this, which asks, I forget whether the homework is to 0 or to infinity. Does anyone know? Has anyone done it? It's like the last one on our homework assignment. Should have done it because it was, well.
0.
It's something like, find the values of the p's for which this converges. Or maybe it's 1 to infinity. Okay. Is it infinity or 0? 1. It doesn't matter. Okay. So this guy, for what values of p will this converge? Okay. So, so part of the point of homework is you're supposed to do them and sort of remember how they worked. Seems nobody remembered how this worked, or they didn't do it, one or the other. Yes, p less than 1. Why? Because when you do out the integral, if p is less than 1, then the x goes to the top when you integrate. And so that means that this 0 becomes a 0 rather than blowing up. But all of these 1 over x to the p's look like that, near 0. And you can't tell just by looking. And this, non-zero, 1 to infinity, dx over, let's put a q here just to differentiate it. This guy converges for q bigger than 1. For the same reason. Q. For the same reason. And when p or q equals 1, it diverges in both places. And you can just, I mean, you did just do this, unless you didn't do your homework and then came on. Okay. So let me move along to the next topic, which is physics, apparently. Projectile motion. Actually, it doesn't matter. I'm not going to use this. Okay. So, you are now supposedly experts on improper integrals and techniques of integration. We'll find out next week whether that's true. And then the next topic that we're doing is returning to the idea of finding, well, let's say, this is easy. Suppose I have two curves here, like y equals x, and of course, since I neglected to bring my notes, y equals, put that at 1, x minus 1. No, that's not the right one. Why can't I do this? How about 4 minus x squared? Let's just do this one instead. So 4 minus x squared looks like that. And what I want here is this area. So this is not a hard problem, because you just have to view it properly. This is an integral, and in order to find the area between the curves, you just subtract the bottom curve from the top curve. So the area between is just going to be, well, I mean, let's do it a little formally. If we make a little rectangle here, its height, because remember when we're integrating, we're adding up the areas of little rectangles, its height is going to be from here to here, or from here to here. So this is 4 minus x squared minus x. So the height of my rectangles is 4 minus x squared minus x. Top curve minus the bottom curve. And so the area is the integral from somewhere to somewhere of 4 minus x squared minus x dx. Now we have to figure out where the somewhere and the somewhere are. There's a well-defined area here. I'm not telling you where they cross, but you've got to figure it out. So we have to find this point, and we have to find this point. In order to do this problem, we have to find those 2 points. So how do we find those 2 points? Okay. We wait for me to do it. So how do we find those 2 points? Okay, right. We set them equal to each other. So we need to know so that means that we rewrite this as, let me bring it over there because I like reading, x squared plus x minus 4. So I need to solve that. Well, that's icky. Doesn't factor nice, but that's okay. I know the quadratic formula. It is -1 plus or minus the square root of 1 minus 4ac over 2. So it's two icky numbers, but they're numbers. -1 plus or minus the square root of 17 over 2. That's when they cross. Nothing wrong with the square root of 17. It's perfectly good. Do not use a calculator, just write that. And so now we know where they cross. This is where x is. This one is -1 minus square root of 17 over 2. And this one is -1 plus square root of 17 over 2. Okay. So that means that the integral we want to do is from -1 minus root 17 over 2 to -1 plus root 17 over 2 of that. And that's easy. That is 4x minus 1/3 x cubed minus, minus x squared over 2, evaluated from blah to blah to blah to blah, which is, didn't leave enough room on the board, so come over here, which is 4 times -1 plus root 17 over 2 minus 1/3 -1 plus root 17 over 2 1 plus root 17 over 2 minus 4 minus 1 minus root 17. So these numbers are ugly. Is there a third somewhere? Minus. But there it is. It's enough. Yeah. Plus one. Sorry. Because I miscopied. Because it's hard to see around this computer. So it's easier for you. You can just look at your paper. And then you simplify this and you get a number. And I'm sorry I chose a big here. Right? Which, I can simplify it if you really insist, but I don't think you're so interested in watching me do arithmetic and do it wrong. Okay, so that's a pretty easy idea. When we have two curves that cross one another, to find the area between them, we just subtract. Notice that you can crank this idea up a little bit. Sometimes, in fact, let me just give an example that I know works. I don't want that one. I want that one. Okay. 1/2 y squared minus 3. And y equals y equals x minus 1, y squared 3x minus 1. Terrible having a short memory. Y squared equals 2x plus 6. So I want to find the area between those two guys. And here, this is y squared. So this is a parabola going sideways, right? So if we look at the picture here, y equals x minus 1 looks like this. And y squared equals 2x plus 6. This is the same as saying y squared minus 6 and 2 equals x. So, I'm sorry? No? Okay. Somebody said something. Just go over here. Okay, if you prefer, if it makes you happy, so either I can do that, or if I prefer, I could say y is plus or minus the square root of 2x plus 6. The same to me. Okay. So when 2x plus 6 is, so here this is a parabola. Well, this is the top half. Sorry. Either one, they're the same to me. So this guy is 0 when x is negative 3, and so is this guy. So this here at negative 3 looks like this. I mean, it's not level, but okay. And then this piece, so that's this piece. And then this piece looks like that. And we're looking for the area here. Now, let's think about, so let me not do it this way. Let me start it this way. The way, wherever he is. There you are. You suggested even though you didn't know you suggested. So let me do it this way. This is the hard way. Why is this way hard? Number one, square roots suck. But number two, let's look at this. So the area is the top curve minus the bottom curve. We integrate. The top curve here is always this guy. Let me write it up here. Y equals plus square root 2x minus 6. And the bottom curve is not always x minus 1. Because it changes right here. So in this region, I have a different bottom curve than I have in this region. So I can set this up, let me not even find the points yet, as the integral from negative 3 to some point here, let me just call it A. The top curve is the positive square root, the bottom curve is the negative square root. So it's minus a minus. So that's this area. And then the other area, this one's on, so plus the integral from A, we call this one B, which I just didn't even find yet, A to B of the top curve is still that square root, and the bottom curve is x minus 1. So that's certainly, that's this area. That certainly represents the area. The integrals aren't too bad. I can do those integrals. They're both easy substitutions. I can find the points A and B without too much trouble. But I have to do two integrals. I have to hurt my brain to think about it. You want me to do this? No? So you can do this. It's fine. You'll get the right answer. Let's find A and B. Well, yeah. Let's find A and B anyway. Do I need them? Not really. So A is where the negative square root, well, where 2x plus, no, negative square root 2x plus 6 equals x minus 1. That's to get A. And B is where x minus 1 equals plus the square root. Yeah? 2x. From being unable to read. They're all pluses. I just can't read. Yeah. They're pluses. I just wrote the cross. Very small. Okay? So, I can find these points A and B. That's the area. This is a sucky way to do this problem. I mean, it's okay. But we can also do it another way. We can just lay down. We lay down. Then the problem is a whole lot easier. Right? So sometimes it's good to be lazy. Of course, if you lay down on the other side, it's fun. So if we look at this problem, it's a bad picture. Well, I don't know where that is. I don't care. If we look at this problem from the side, notice that these guys always have the same curve. From here to here. If you look at just the y values, x minus 1 is always bigger than the parabola. You have to lay down. Right? Going up is it's like this way and this way. Because this is the increasing pattern. So if we slice it sideways instead of up and down, this curve, the right curve, and then we integrate with respect to y. So the right curve, y is x minus 1. That's already, so x is y plus 1. This curve on the right is x equals y plus 1. And the curve on the left is, I wrote it down and then erased it, x is y squared minus 6 all over 2. And so that means that this area is the integral from y plus 1 minus 1/2 y squared minus 6 dy. I already used a and b, so let's use c and d. We integrate from c to d. But those are the y values where they cross. So we want to find the y values where these two things cross. So the c and the d solve y plus 1 equals 1/2 y squared minus 6. So part of this, and in fact you should be thinking this way, this is part of why it's useful to think about the little rectangles. Here my rectangles are laying down and they go this way. It makes my life easier to cut it sideways instead of cutting it vertically. I guess I might as well solve this. So that's the same. 2y plus 2 is y squared minus 6, which is the same y squared minus 2y minus 8 is 0 is 0. And that one factors, right? Think 2 and 4. So that guy factors. So this is y minus 4 times y plus 2, 0. So that means that my, who is C? C is negative 2 d. So that means that my integral is from negative 2 to 4 of, well, it's all there anyway, right? Y squared minus 2y plus 8. No. 1/2. Let me leave the other way. Okay? And then this integral is easy. Just multiply it out. So the upshot of this is you want to think about how we're slicing up the object. And if it's more convenient to slice it horizontally, go ahead. In fact, if it's more convenient to slice it, well, whichever way it's more convenient to slice it. Now sometimes, maybe the curves cross 3 times. Does anybody want me to finish this integral? I'm happy to do it if somebody wants me to. Yes, you do? She wants me to finish this. So, this is, let me just do the algebra here. This is minus 2 to 4, minus 1/2 y squared plus 3 plus 1 is 4 plus y dy, which is minus 1/6 y cubed plus 4y plus 1/2 y squared evaluated from negative 2 to 4, which is minus 1/6. 4 cubed is 64. So 4 times 4 is 16. Did I lose a minus sign somewhere? No. And half of 16 is 8. And then we subtract off. Negative 2 cubed is 8, so this is 8 over 6. Negative 2 times 4 is negative 8. Negative 2 squared is plus 4. And then you add. So, let me point out, this is not a class in arithmetic. So, if you have things like 1/2 plus 5/12 plus 3/19 on the test, you just leave it that way. Take care that you get the 1/2 plus 5/12 plus 3/19. And whether you can add fractions or not, it's not really my concern. I can. So why should you be able to? I mean, I can, okay, but I don't want to. So my concern is that you understand the material well enough to get an answer. That does not mean that you cannot, that you can just leave something like the sign of pi as the sign of pi. You should know that the sign of pi is 0. So I need you to do the obvious, and I would prefer that you not leave 8 over 4 as 8 over 4. You should know that 8 over 4 is 2. But if you don't want to add 5/12 and 47/19, I can understand why not. Okay. So this is some stuff, and I'm going to leave it to you to do that. guess I have time for another one. Let me just think about. Okay, so I have to write something down. Sorry. X What? Let me find it. This is on the midterm. And unfortunately, I was so worried about all this technology garbage that I left my notes sitting on my desk, and I can't remember the problem that I worked out. Doesn't matter. Okay, so notice that sometimes maybe your curves cross more than once. Sorry. Okay, so sometimes your curves cross more than once, in which case you have to split up your inputs. Right? It's always important to remember that your area is the top curve minus the bottom curve. So in this case, let's just call this F, call this G. So this point is 0, this point is A, this point is B. So this area that I want is going to be the integral of F minus G dx plus from 0 to A plus the integral from A to B of G minus F. This is really what you did when you were finding areas under curves. It's just that the curve, instead of being exact, this is now pulled up. It's the same thing. So, maybe we'll get through this, who knows. Let me just, none of these are like, okay, why is this back to this? So let me do another example. So say I want to do this one. What curve is on top? So let's call this one F, and let's call this one G. Nobody knows?
Absolute value.
Why don't you vote for F? Okay, this is a good sign, right? You can just look at 0. At 0, this is 0, and this is -2. That's a hint. So, y equals x squared minus 2 looks like that. And the absolute value looks like a v. So this is value. Now, both of these are even functions, so I can do this in two ways. I can either integrate from here to here, and then from here to here, or I can just realize that the area over here is exactly equal to the area over there, so I can just do this half and double. Either way is okay. So when when do these cross? So I guess one thing, let me point out, just remind you, the absolute value of x is x if x is positive, and negative x if x is negative, right? This is another way to read this is, if what's inside the absolute value is positive, leave it alone. If it's negative, change the sign. So students mess this up all the time. Don't panic when you see absolute values. Just remember that they change whenever what's inside changes. And so here, we need to know, when does x equal x squared minus 2? That will tell me this intersection point over here. So that is x squared minus x minus 2 equals 0. And then the square root here. So that's what? Yeah. What? Okay, so x minus 2 times x plus 1, doesn't it? Yeah. Okay, good. That makes it easier. And so that happens when x is 2 or x is negative 1. But the negative 1, I don't want. That's here. Because I only looked when x is equal. And also, if I looked on the other side, I would get negative 2. So this is the one I want. And so that means that this area is the integral from 0 to 2 of x minus x squared plus 2 dx. And then I can double it, because it's the same as the integral from negative 2 to 0 of negative x minus 1. Okay? And that's probably a good place to stop. Before you pack up and leave, let me remind you some things. The paper homework, because we have a holiday now. Oh, let me remind you first, today is Friday. The calendar may say Wednesday, but today is Friday. So if you have recitation on Wednesday, no you don't today. If you have recitation on Friday, yes you do. Paper homework is due after the break. There's another web assigned due. It only has 7 problems on this stuff.